Hi friends, a very warm welcome to you all. Now let us continue our discussion in the topic relations and functions in class 11 and 12 mathematics. I hope you all remember the earlier portions covered. So we have covered sets and what else? We have covered a lot of discussion on sets and we covered a topic called relation. This topic of function is actually a continuation in the topic relations and they are actually usually mentioned in combination or as a group. We all usually say no, instead of functions alone, we say relations and functions. Why they are related? So guys, let's see. First of all, I am not going to take you directly to mathematics. Let us now look at a daily example of a function. Something which everybody knows, digestion. What happens in digestion? Your food which you eat, it goes into our body and through the alimentary canal it goes to our mouth, then like this it goes and it goes to the stomach and back, then it goes from the stomach, it is means what at all hydrochloric acid and such enzymes are released, and then it goes through the another tube into the small intestine, and here the pancreas, liver and all give their enzymes, and in the small intestine the main process happens of digestion. But let us think of each step in digestion. When you eat your food, first what happens? Chewing. You first chew plus saliva. It's happening in the mouth. Then it goes through the tube and that and all. We don't want to digestive tube and all that. We don't want to consider. Then what happens in the stomach? There is the action of hydrochloric acid. Then there is the action of enzymes in the small intestine. Right. Each of these performs some operation on the food that we eat. Right. There is some operation that is performed on the food, and what happens as the result of all these operations? This food is converted into some simpler organism and it is assimilated. It's absorbed into our body. So, we will not consider after that absorption. Actually, after the absorption, the process of respiration should start. So, we are considering only digestion, the main essence of digestion. In the digestion, the food goes into our body and there are many processes are performed, and as a result of sequence of operations, it is converted into output. Each of these operations, let's say 1 plus 2 plus 3, there are only 3 operations, and these 3 operations together convert into output. This sequence of operation is defined by the function of digestion, or we'll usually call it a process, but it can also be called a function. This function of digestion defines the sequence of operations to convert an input into output. The sequence means it is not a define, basically I mean it covers, it encompasses some processes, some operations which convert the given input into output. Like carbohydrate, we have glucose. Right. For carbohydrate we have glucose, and for fats we have fatty acids. So this is the process of digestion. Now, let us come into a mathematical language. What did we study here? See, there are many operations which are included in a function. Many operations are included in a function, and together they convert an input into output, a given into a given output, given input into a given output. There are many functions which have many outputs, but in mathematical language we only take the one output for one input. One output for one input. This is what we take in mathematics. Now what are these operations and what is this function? Like we know only basically four operations: addition, subtraction, multiplication, division. Addition, subtraction, multiplication, division. To this let us add exponential, means e raised to x, logarithm, log, log, and let us add modulus, and let us add the greatest integer. Right? Like I will tell you what this log, these four things I will tell you later. It is coming in this function only, this topic of function. We will discuss that deeply later. But let us add these things. And let us say, even if you want, you can add percentage. And let us say x raised to y. Do you know what is x raised to y? If I say 2 raised to 3, then it should be interpreted as 2 into 2 into 2. 2 coming multiplied 3 times to itself. That is 2 raised to 3. So all these things, these operations will be put into some sequence. In a sequence, there are many sequences which we can combine, but a particular sequence, when they are performed, it will convert a given input into a given output. This is a function. This is a function. The sequence of operations that converts a given input into a given output is called a function. And in mathematics, even when there are more than one output for a given input, upon performing this sequence of operation, we will be defining a function only if there is just one output for a given input. Now, there are a few concepts related to functions which we have to discuss. There are a few more concepts related to functions. And the first one is, now we are not going to any other process of digestion or respiration, we are just picking up our principal object, that is numbers, variables, which concludes mathematics. Now, what do we have in these concepts? First one is first we learned about function, then we are going to learn about domain. What is this domain? See, a function need not be performed on just one object, right? It can be performed on any number of objects. The number of objects on which this function is performed in a given study. It is not necessary that this function cannot be performed in any other object, but for this study we are performing it only on a given set of objects. You know what is a set? This set on which this function will be performed is called the domain. Now, range. Upon performing, this domain will be denoted as d of f, and this function will be denoted as f for g or u and d you can give, and this is denoted as d of f, and range is denoted as r of f. In d of f, upon performing this function, we get, this is function, we write like this, it is given function. Like we denote sets by a, b, c, d, we are denoting function by f, g, small letters, capital, not capital. Alright, so this, upon performing this function on a given domain, we will get a set of values, the output set. That output set is called range of the function. This output set is called the range of the function. But tell me, whenever we define function, do we usually tell from this domain to this range? We don't usually tell. It is not that we don't usually tell, it is that we should not tell. It is that we should not tell. We usually tell that set for function from A to B. That is, the initial input will be in set A and the output will be in set B. Tell me something, is it necessary that all the elements in set B are output of some element in set A? If B has 10 elements, is it necessary that each of the 10 elements is the output when the function is performed on some element of A? I will define some more concepts. You will understand it better. This initial input is called the pre-image. Okay, the input we call the pre-image, and upon the performing function on this input, when we get the output, that output is called the image of this input on this function or on this set B. Alright, now let us take a function of x plus 1, and let us say A contains set of 1, 2, 3, and B can be set of 1, 2, 3, 4, 5. Now tell me, we are performing this function f on each of these elements, and upon performing this we get this range. What will be the range? Let us compute the range of this function. The range will be x plus 1. X is this item. 1 plus 1 is 2. 2 plus 1, 3. 3 plus 1, 4. Now tell me, are 2, 3, 4 elements of B? Naturally yes. Of course it's yes. 2, 3 and 4 are elements of B. But they are not the only elements of B. There are 1 and 5 are also there. So this set B encompasses or covers this range of this function. Such a set which covers the range of this function and it contains all the images of this function when performed on the domain is called a codomain. There is no CD and all for this. We will just say codomain. So we will write like f is from A to B such that f of x is equal to x plus 1. This is how f is defined. This is how f is defined in technical terms. There are many more concepts to cover in this topic. Even the basic introduction covers many more topics, and we will have to cover a few general functions which are very important. This includes some of the operations which I had told you. We will have to learn that in detail. We will have to learn those functions in detail, and we will have to learn one important concept related to function, that is graphing, which I will discuss in the next video. So till then you can do an in-depth discussion yourself on whatever I have told you. We have learned about functions, domain of the function, range of the function, codomain of the function. But now tell me something before I conclude. Is it true or false? Range of f is a subset of or equal to codomain. Range is the subset of codomain. It can be a proper subset or it can be the codomain itself. Is it true? Naturally it is true. Here it is a subset. But if it had been that we had added 0 and 4 to A, then it will be that 1, 2, 3, 4, 5 will be the range. So it will be the codomain itself. So always range is a subset of the codomain. This is an identity which you can have. So this is all about today's class. I hope you found it useful. Meet you again, and so till then have a great time. Bye bye.